In 2018 alone, 1,137 people were killed in road-related deaths. That's over 3 people a day, and things have not gotten better. In 2019, so far, there have been 729 deaths, an 11.5% increase from the same period last year. These statistics are incredibly confronting, yet avoidable. A death toll that reaches 1,137 could be brought down to zero with the implementation of driverless cars in our society. That's where our product comes in. Our product is a prototype for a driverless car that uses its capabilities to make the roads safer and more manageable. We have done this by utilizing the many hardware and software components made available to us. Components such as sensors can help us to demonstrate the typical features of a driverless car, and the ability to program the MBot allows us to customize and adapt the product to different situations. Now let's take a look at the hardware side to understand how this product truly functions. We developed our prototype using the starter kit made available to us for the MBot. With this kit, we constructed a self-driving car equipped with line followers and ultrasonic distance sensors. This allowed us to demonstrate the typical features of a driverless car easily. The line follower uses infrared light to detect where the line is so it can follow it, similarly to how a driverless car would detect and follow the road. The ultrasonic distance sensor allows us to detect objects in the path of the MBot so that it can successfully avoid them, a feature that is essential to a driverless car. With the use of these sensors, we can test the capabilities of our driverless car and, if needed, solve problems that arise. Now let's take a look at the software side of the MBot. Our prototype uses a variety of applications and methods in coding to complete its function. This can be summarized into 3 main operations: line following, object avoidance, and passcode protection. These 3 tasks allow us to showcase the features of the MBot that make it eligible to be a driverless car. The first operation is the line following code, in which the MBot is programmed to follow a line based on the infrared values received by the line following sensor. The second operation is the object avoidance code, where the MBot utilizes an ultrasonic distance sensor to detect any objects in its path and avoid them. The third operation is the passcode protection, where the computer stops its driverless car code from being uploaded into the MBot until the correct passcode is inputted. All of the software comes together to make the coding needed for a prototype solution of a driverless car. With the implementation of this incredibly resourceful software and hardware, there are a number of ethical issues that arise, the most prominent of these being the object avoidance code. Due to the way that it is coded, the MBot will have to constantly make decisions on whether or not to keep driving forward or change its course based on objects in its path. This brings to light ethical issues, such as the amount of trust that we are putting into this machine that has no moral compass or accountability. If we look at this issue from an objective point of view, we understand that the prototype will sense that there is an object in its path and in response will turn to avoid the object. If we look at this from a subjective point of view, we can see that this form of avoidance does not take into account the possibility of the trolley problem, and the bot is not designed to handle such an ethically compromising issue. Another decision made by the MBot is the unlock feature that is protected via a passcode. This is not as ethically compromising of an issue, as it doesn't endanger any lives or put anyone at risk. From an objective point of view, this is simply a safety component that decreases the chances of the car getting stolen or accessed by an unfamiliar individual. From a subjective point of view, this could be a feature that upsets older generations who don't understand the technology, limiting the number of potential users who are kept safe by the car. A third and final decision made by the MBot relates to its ability to stay on the road based on the line following sensor. This decision directly impacts the safety of the pedestrians, bikers, and other drivers on the road, and hence needs to be discussed. From an objective point of view, the MBot uses infrared signals to stay on the road and to ensure it does not veer off course, but from a subjective point of view, the other people using the road might not feel safe knowing the fact that a machine is controlling a car that could possibly malfunction and put themselves at risk. As seen by the issues brought up by the prototype, it is clear that there is room for improvement, but this does not take away from the fact that it is projected to save thousands of lives every year, a marvel that truly benefits our society and is a step in the right direction for our future.